In lesson 93, we are working on some advanced trig identities, and you know by now all this means messier proofs. And I'm going to kind of try to model with you how we might think through what is happening on these things. So, show that this is true. And I first look at that, and it's like, well, I know I'm supposed to look for squares for Pythagorean identities, but I don't have any of those. And let's see, I don't have any of my double angles or half angles, so none of those formulas are going to help me. Well, my other trick is change everything to sine and cosine, but it's already there. So what I'm going to do here is I'm going to start by writing down that first side. So 1 plus sine b over cosine b, because I know I always have to copy down one side just like it is. None of my other tricks are really working for me. So I'm going to look at that right-hand side. And you know, I want to end up with a 1 minus sine b in the denominator. So I'm going to say, well, I want a 1 minus sine b in the denominator, so I'm going to put 1 there. But I can't just do that. If I multiply the denominator, I've got to multiply the numerator by the same thing. And the way that I wrote that right now means I'm only distributing the sine b of this first part to the parentheses, but I need to multiply the entire numerator, so I've got to put parentheses around that one since I had a plus sign out. Okay, now that I've written that, what do you guys think might make sense for me to do? Etienne. Yeah, let's distribute the top, and let's be smart as we do it. They're exactly the same, just one with a plus and one with a minus. So I know when I FOIL, the O and the I are going to cancel out. So I'm just going to get 1 minus sine squared of b up there. I know I want to keep a 1 minus sine b in the denominator, so I'm not going to change that by distributing, which means I better keep my cosine b right there. Don't forget your equal signs in these. Some of you aren't putting them in, and it's very hard to tell where one step ends and another begins. Okay, now I've got 1 minus sine squared b in the numerator. What can I do with that? What can I do with that, Liam? Hey, that sounds like a great idea. Pythagorean identity. Let's change that to cosine squared of b. And then what do you notice? What do we notice now? Henry, what do you notice at this point? Yeah, let's cancel one of the cosines, and that's going to give us what we wanted on the right-hand side. Sine b over cosine b, and then you multiplied the numerator and denominator by the denominator you wanted to have. Well, why'd you pick the denominator? Why didn't you do it and just say, well, I need a cosine in the numerator, so let's put that in there? Answer is I certainly could have. And here's what would have happened. I could have done, I need a cosine b in the numerator, so I'm going to put it there, which means I'm going to put 1 down here in the denominator as well. Okay, that's going to give me, now I don't want to cancel it back out, because that undoes what I just tried. So I'm going to keep the numerator as cosine b, and I need to put my parentheses around that since it had a plus sign, times the 1 plus sine b. And now I'm going to say my denominator is cosine squared b. I want to keep that cosine b in the numerator. What can I do now with cosine squared of b? Micah, you got an idea? Okay, let's give that a try. Sounds good to me. So we're going to change that denominator to 1 minus sine squared of b, and we'll still keep the cosine b that we want in the numerator, and we've still got that 1 plus sine b along there. Now what? Charlotte, you have an idea? Yeah, that denominator is a difference of squares, so let's just factor it. And then we have something that cancels, and that gets us back to the cosine b over 1 minus sine b that we wanted and that we got doing it the other way. So does that kind of make sense? And I'm trying to model the thought process that you guys are going to go through, because they're no longer just obvious, one little step, and this is what you do. You've got enough tools that's like, well, what should I do with this one? And you think it through, and sometimes your first idea doesn't quite work. All right, so here's another one. Okay, what in the world do I want to do with this thing? So, well, let's copy down 10b plus 1 and 10b minus 1 and see if we can come up with anything that might work with this. So, let's see. Got a tangent there, and I want to get a secant. What am I going to do to get from tangent to secant? Not going to just give up. I'm going to keep thinking about it and trying some stuff. You have an idea?
You could multiply by tangent b minus 1 over tangent b minus 1.
And I probably could, but that won't get me to both secant and cosecant. Probably. That'll probably just get me to secant. Hey, bye. Well, let's try that. That's always been one of our basics. Let's try. If we write that as sine b over cosine b plus 1 and sine b over cosine b minus 1. And then my next thought might be, I've got fractions inside fractions. Maybe I want to get rid of that. So don't copy this down yet. Maybe I try multiplying by cosine over cosine. So then I wouldn't have fractions, but then I'd have sine plus cosine, and that's not real helpful. And sine minus cosine, and that's not real helpful either. So I think I'm going to try to come up with something else to try. Okay, you know, I want a secant. A secant is what with sine or cosine? So I know I want to start off with a 1 over cosine up there. So maybe I want to keep that cosine and just get rid of that sine in that first term. So my next thing I'm going to try is, well, what if I multiply the whole numerator by 1 over sine b? Because then I'd have 1 over cosine, and I'd at least be starting with the secant that I'm going to want. But if I do that in the numerator, I've got to do that in the denominator. This original numerator had a plus, and this one had a minus, so they need parentheses. Okay, let's see if this gets us anywhere. I may end up erasing and trying something else. But let's see if this gets us anywhere. So when I first distribute, that first term becomes 1 over cosine b. And my second term becomes 1 over sine b. I don't know if this is going to help. This is getting messier by the minute, isn't it? Let's see, then we distribute, and the signs cancel, and we have 1 over cosine b minus 1 over sine b. What do you think? Is this getting me anywhere, Joshua?
Yes, yeah, because I need to break down further secants and secants.
Oh, help me do that. So 1 over cosine b is what?
Secant b.
And what's 1 over sine b?
Secant b.
Hey, that is looking good. That does match the numerator. And same thing for the denominator. And that's what we want. Okay, let's do something really nice. All right, copy down first side. X sine theta plus y cosine theta squared plus x cosine theta minus y sine theta squared equals. Okay, what do you want to try? Sydney, what do you think we ought to try? Yeah, we really don't have much choice. The only thing we can do is basically FOIL everything out, expand it all out, and then see where we are. So x sine theta times x sine theta will give us x squared sine squared theta. And please proofread as I'm writing that I don't leave out any exponents or signs or get anything wrong in there. Then I'm going to have x sine theta times y cosine theta, so that'll be xy sine theta cosine theta. And then I'll have y cosine theta times x sine theta, so I'll get another one of those. And then I'll have y cosine theta times y cosine theta, so I will have y squared cosine squared theta. And then I do the same thing with the other parentheses. So then I'm going to have x squared cosine squared theta, but this one I've got a minus. So I'll have minus 2 of the xy cosine theta sine theta or sine theta cosine theta. And then minus y sine theta times minus y sine theta will again be plus y squared. And now a sine squared of theta. Did I get everything right in there? Alex, what's something you notice now? As we try to simplify that, what's the easiest simplification in all of that to do next? Is there anything in there we can combine or cancel? Anybody see anything in there we can combine or cancel before we go on any farther? Brian? Yeah, the two long terms in there, one's plus and one's minus. Let's get rid of them. I like getting rid of anything I can in something this long. Okay, now what I'm going to do, I want to put my x terms together, and then I'm going to put my y terms together. So on my x terms, I have x squared sine squared theta plus x squared cosine squared theta. And when I put my y terms together, I have plus y squared cosine squared theta plus y squared sine squared theta. And then let's try factoring the x squared out of these two. And let's factor out the y squared on these. And now I need somebody to tell me what you notice. What can we do now? Me? So the sine squared plus cosine squares are both 1s. So I just got x squared times 1 and y squared times 1. And that's just x squared plus y squared, which is what I wanted to have here. So just messy, but not that hard to understand. And one last one for today, and then we're done with all our new material. And this one really isn't that bad to try to do. So let's start off, that left side's longer, let's start off with it. So copy it down, don't change anything yet. Sine squared x plus cosine 2x over secant x. Give me an idea of what to do next. Willie Rose?
Can maybe change the sine squared x to 1 minus cosine squared x?
I might try using my Pythagorean identity on that sine squared of x. And then that's going to give me some cosines with 2x and cosine with x and secant with x. And I need to end up with just cosine of x. So somehow I'm going to have to get rid of that 2x in there. So Ryan, you have an idea of something we could try?
So cosine 2x could turn to cosine squared x minus sine squared x.
Let's give that one a try and see what happens. That would let me have 2 sine squared of x. And then just for emphasis, I'm going to put parentheses to just kind of show you what I'm doing there. I'm changing cosine 2x to cosine squared x minus sine squared x. And that's over secant x. Now what is happening in that numerator? What's going on with my numerator now? What can I do with it? Isaac, any ideas? A little louder, please. Well, we always want to look, is there anything we can simplify? Do we have any like terms we can put together and make things a little bit easier to deal with? Ben? I've got 2 of the things minus 1 of the things. So if I put those together, I only have 1 of the sine squares. And then I still got that cosine squared. Wait a minute, now what? Isaac, now what's my numerator? So now my numerator is 1, and everybody, what is 1 over the secant? 1 over the secant is the cosine, and that's what we wanted. Anybody with questions today?